Right. Okay, so some point that's going to turn on. So today we're starting the last new material for this chapter. Yes?
When are we going to go over the second half of our test?
Soon, my friend. But because it doesn't impact what we're doing right now, I don't feel a huge rush. So as soon as I have a moment, like I won't have a moment today, but I might have a moment tomorrow. And whatever we're going to cover today, guys, and we're going to be doing cross-sectional volume. I picked the right time to leave. Oh, not my problem. So whatever we're doing today, we're going to talk again about it tomorrow on Wednesday, and then we're going to review everything on Thursday, tests on Friday, and then we've got one more unit left in calculus, and that unit will take us through the beginning of March, and then we'll start reviewing. And I may have to do the review totally different this year because I'm down like 8 days, and the way I have it now, at best I can get part of a practice test in, and another one that if you want, and this will be optional, but I'd strongly encourage it because people who do it really do much better on their AP test. The Friday the 16th is our weather day. I do an optional test that morning where you can come in, take a full-length practice test, and then zip out. When's y'all's prom? Y'all even have a prom schedule? The 17th, which is Saturday. So this would be that Friday. I'm assuming that we might be past the worst of the weather, but you never know. I had snow on me once on March 20-something here. So anyway, we'll see. But this is the last material. So stay with me and see if you can process through what we're doing. So what I'm going to be doing here, and I've got a nice, cool little program to show you this stuff with. And it keeps blowing up. What's going on with my computer? Okay, so I've got this program, and I've used this thing before. Imagine this. Imagine this circle. And by the way, does not matter what region I'm talking about. I'm actually not even looking at this as a circle. I'm looking at this as a top function, which happens to be a semicircle, and a bottom function. More than likely on your test, you'll have some like parabola up here and some line down here. So when we're looking at these, don't look at this circle and think that that has any significance here. It doesn't. We're talking about two functions, y equals the positive semicircle and the next, y equals the negative semicircle. So imagine I have two functions, and instead of just finding the area between them, like you were just doing, top minus bottom, what if I wanted to build on top of this? Think of this as like a piece of wood, okay? And I want to build volume on top of it. Like literally create some volume. And I want to create that volume in different shapes. Maybe I want the shapes to be triangles. So there's a bunch of triangles coming across here. Maybe I want the shape to be semicircles. Maybe I want the shapes to be squares. Whatever. But whatever the shapes are consistent all the way across. So that if I ever slice into this volume, I get the same shape. Just a bigger shape maybe, or a smaller shape. Now this program shows you this. I'm going to drop down this y-axis so you can see it. So the idea is, what would happen if I this is going to be a square. If I took a square and swept it from left to right, check it out. So as I sweep this thing across, you see how as the base increases, because it's square, the height has to increase. And as the base decreases right here, the height has to decrease. Y'all seeing that? So as I'm sliding this around, you can see, I'm screaming. As I'm sliding it across, I can see that I create this solid. Are you with me? And that solid, I'll go ahead and let it finish because it's kind of cool. All right. As it finishes right here, I can see the solid. So when you come in here, if I were to ever slice into this thing, I know it kind of looks weird here, but you can see if I were to ever slice in there at different spots, I'm going to get squares every time. Are y'all seeing that? Now, if I asked you, based on this information, how could you find the area of a single square? How do you find area of a square? Well, it's even better than base height because the base and the height are the same. So it's base squared, right? And how would I find that base right there? I'm going to get rid of these 4 squares. Okay, how would I find, for instance, on this square right here, it looks something like this. How do I find that base? If that's the top function, and that was the bottom function. Top minus bottom, right? Now, it doesn't seem like a top minus bottom now because remember, I laid the axis down. But if you think about bringing that axis back up, that was just top minus bottom. And then if does that make sense to everybody? Yes? So if the top minus bottom gives me the base of my shape, and a square is just a base squared, then I could take that top minus bottom, whatever that function is, and square it, and I would have the area of the square, right? Now, do you remember when we were just doing area a second ago? You were doing top minus bottom to just find a height. What did the dx do? Dx is like change in x. What did that do for you? Think Ramon's sum. If I take a height and multiply it by a tiny base, it turns height times base into what? Area, and then the integral sums all those areas together to give you a big area. Well, what if I take area and multiply it by dx? What do you think that gives me? Thin volume. Think about it. If I take this and I multiply this by a little bitty width, well, then all of a sudden, I don't have area anymore, do I? I now have a volume. So when I do this, this represents area. When I dx it, it represents now, this is like the area is like the base. The dx is like the height. And if I take area times height, all of a sudden now I have what? Volume. Except I don't need the volume of just one little like thick sheet of paper or whatever. What I need to do is now sum this all the way across from A to B, or in this case, -2 to 2. How do I do that? That's where the integral comes in. Is that making kind of some sense? So it's basically, you're doing the same thing you did with when you calculated area. Area just took a bunch of heights, right? All the heights all the way across your figure by going top minus bottom. And it gave each one of those heights a dx. That's what that does. And by taking a height times a dx, it turned those into a bunch of little Ramon rectangles. And then you summed them all up. And that gave you all the area between the curve. That's what you just did on your quiz. The only thing I'm doing now to find volume is I'm taking a bunch of areas, a bunch of area top minus bottoms, right? Because top minus bottom gives me the base, but when I square it, it now gives me base times base, which is area. Area times a bunch of little widths. Are you with me on that? Area times a bunch of little widths right there. Sorry, that's kind of like area times a width. I don't know why I said height. Area times a little width. That gives me volume. It's like taking a thin sheet of paper that you could, you know how when you look at paper, you're like, okay, there's area, but it's kind of hard to measure volume because how do you measure the width of a sheet of paper? But that's what the dx does. It gives that area just a little bit of width, and then you sum all those volumes together. That's a square. Now, do you think it changes any if I change this from a square to a right? Sorry, let me go back to the circle. Right here, what if I used, I'm going to drop it again. What if I used triangles? Well, you can't see it there. What if I swept right triangles across? Same kind of situation, right? What's happening on this right triangle? As the base increases, the height's increasing too, right? Now, they would have to tell you something about the height there. Now, if the base and the height are the same, which I think they are here, we could say, well, what's your area of a right triangle? The area of a right triangle isn't the same as a square. Square is based on space. Area of a right triangle would be 1/2 base height. So you would have to know something about the height. Okay, but what about this? What if I told you, hey, the height is 7? Always. Height's always 7, but the base is changing as you do your sweep. Well, couldn't you say in that case, let's think about it. Area is 1/2 base times height. So if I told you the base of this is top minus bottom, right, and the height is always 7, I have the area of your triangle, don't I? What happens if I give it a little width? Now I have what? A volume, and what if I add them all up from -2 to 2? Now I have volume of everything, except I would probably factor out the 7/2, so I don't have to deal with it. What if I told you your height was 7 times the base? Then what would I do? Now I have what? If the height is 7 times the base, what do I end up having? A 1/2 and a 7 and a base times a base. What can I do for that? 7/2 base squared, and your base again is what? Top minus bottom. And you can integrate that, give it a little width, turn it into volume, integrate that from -2 to 2. Now I have to tell you something about the height. What if I said it was a rectangle? Well, rectangles are just base times heights, right? So if it's a rectangle, and I told you that, hey, your height is 7 times your base, what changes? You just don't have a half in there, right? Are y'all kind of processing through this? Now here's the trickiest one. What if I told you, I'm going to do that on a different one. What if I, what if I told you, okay, you're going to have a horizontal line, a slanted line, a vertical line. So here's my region. What if on this region, I want to build semicircles? Now this one's a little bit different, but I want you to see the idea, because I'm not going to be rotating this way where I could do a top minus bottom. I'm going to be rotating it this way. So I'd actually do a right minus left, but I want you to see this. So what if I took semicircles, and let me rotate this or drop this. Okay, so I'm going to actually do semicircles on this one. Now let me ask you a question. On this one, what do I have to do to find that? And you can see it's changing as I slide this down. What do I have to do to find that length? That base right there is not top minus bottom, is it? It would be right minus left, but you could still find the base, couldn't you? Do I want the base when I find areas of a semicircle? What do I want, Hardy? Seems like you're with me.
You said radius?
Oh, you said radius? Awesome. Sorry, I didn't hear. So if right minus left, think guys, if right minus left gives me the diameter, I just have to do what to find the radius? So I half it. Now I have radius, but I would have to half it first. And then how do I find area of the semicircle? Pi radius squared gives me circle.
1/2.
Another 1/2 on the outside. And by the way, don't get clever and think, I'm going to take that 2 and pull it out. Because it's not a 2, it's a 2 what? 2 squared. So I have 1/2 base, half of the base is radius, 1/2 pi radius squared. That gives me the area of each of these. But I don't want area of those, I want volume of those. So I dy this one, because it's right minus left. But dx if it was top minus bottom. And then just integrate from what? 0 to 4? Well, not on this one. I'm going from there to there. I got to go bottom to top. So I don't know what the bottom to top is. Was it -3? Yeah, -3. So I would have integrated this from -3 up. But the bottom line is you just got to understand these. These are the 4 formulas, the 4 situations. They used to ask for equilateral triangles. And then people are like, well, I forgot my equilateral formula, which is unfortunate. It's supposed to be like s squared root 3 over 4. You might remember that, but maybe not. What do I got? 30 minutes? So let me just show you an example real quickly, this is in the book. You want to look at it. This is my page 167. I think that's yours too. So real quickly, I give you a couple functions, right? I give you a couple functions and I say, let's create squares on top of this. So what would I need to put a square like this, let's just say, or like this, let's just say, whatever. If I would put a bunch of squares on there, I need to know what? And how do I find the base? Top, which is the line. So this would be x plus 1, that's the top, minus the bottom, which is the parabola. And what did I just create right here? That's the base. So what do I do with it? Square it. Now I have a square. Then what do I do with it? Give it a little bit of width. Now I have volume, and then I'm going to integrate from -1 to 2. And what changes? What if I go to a rectangle? Now it says the height is always 1. So what do I want there?
Just one base.
Base. That's my base times height, which is 1, which you don't really need to do, right? And then what do you do with it? Give it a little width, integrate, -1 to 2. Hey, what if I said that the height is 5 times the base? Well, that's what? That's base times 5 base. What do I do with that?
Square it.
5 base squared, and don't bother with this. You see how I can vary this up? Y'all seeing it? And then I got 1 more minute. What if I said semicircle? Now, what is this base doing for me? That means this base is the diameter. So I have to half the diameter to make this a radius. I've got a pi r squared to make it a circle. Half it to make it a semi. You exit and integrate. Bam!
I mean, like, there's no like.
So how do the test corrections work?
Well, it's good you haven't done any to know that. You take a clean sheet of paper and anything that you missed, correct.
Okay.
You have 2 parts that were bad or just 1?
I think they both weren't great. One was only one that was below 80.
I just have 42. Oh, because I haven't gone over them yet. Well, there's the 42 parts. I guess you don't have to worry about that one. The 6. Yeah.
And then also, I won't be here Thursday or Friday for golf, so. I
So
guess
that test I'll just put in the bin and you'll just make
just
it
make
up.
it up. And it's
Yeah.
still with Miss Parker? Or?
It depends on what day you go. Just take a picture of that. It'll tell you where you go.
Okay. Yes, sir. And let's see, do you want me to sit?
Just way in the back because there's like a small class in here, but they're all up front.
Okay. Am I allowed to use my notes to correct it?
Absolutely.
So we're not turning in the video from last night.
No. I'm gonna give y'all everything back you have, and then I may or may not take this stuff up on test day, or I'll let you know. But I want you to kind of have everything if you need to look over.
Boom.
What's up, man?
Hey, how are you?
Good.
Give me a hug.
Good to see you.
Good seeing you.
Excited about your next journey?
I am.
Get my job. I got a job over there.
Yeah. I beat you to it, didn't
I don't know. Maybe by a couple months.
I? I was gonna show you, not that I'm counting soon, but maybe I am, and I'm down to 3 days, 1 hour.
Oh, wow. So it's May the first.
Yeah, March 1st, I start my new gig. So this is it. This is last week.
You just making rounds and stuff.
I literally, I kind of go into a school each day and just sort of, for a couple hours, seeing folks. I want to pop in and see you.
Yeah, this might very well might be. I told mine this might be a coin flip on whether I do a part time.
Yeah. Well, you just, I just had something good fall in my lap. I was gonna go. And this,
Who connected you with that? I
well,
know your CEO. He's a friend of mine from college.
so I saw that. You know, this seemed like a cool guy. He's actually reached out to me, which is incredible, as big a company as it is. But so Lisa Silva, who reports to him, was an old textbook vendor that I worked with for years. And she and I just have kept in touch. And 3 or 4 years ago, I went to lunch with her and just said, hey, I'm getting close to retiring. I'm going to retire on the earlier side, but I have no plans to do. You know, can you kind of help me out, look out for something? And this is someone I trusted. And then lo and behold, she called me when she had something.
Oh, cool.
So, but anyway, I was, he I said, hey, Lisa's really excited you're coming out. She showed me your video that you sent. That's incredible. We're so glad to have you aboard here. I thought,
Wow, he's a good guy. His his wife's in education too. She teaches on the state. Yeah.
But I was just super impressed that that big a corporation that he would reach out to.
You don't realize how big it is.
Yeah. He said, sorry, I have to introduce myself. Electronic. I'm like, dude.
Yeah,
you're
I
the
mean,
cheese.
expecting that, yeah.
Good to
Yeah,
know.
when I heard that he got CEO, I was like,
I heard they really like him too.
oh yeah, yeah, he's class act. Not a big guy, about 5'9". About
Mhm. Good height.
That's right, that's right.
I'll let you work.
Man, great
So
to
look
meet you.
up on screen.
Congratulations.
All right, that's luck to you.
Oh, thanks.
See you around.
Yeah, just knock yourself out. It's got that little chain. Don't yank it. How we doing? Yeah?
Yeah.
All right. So, we want some calculus? Maybe not. We stick to probability. I love this end of the year stuff we're doing in calculus. It's good stuff. I actually like it too. Class averages and usually like A's. It's just always nice. All right, so questions on probability. And as soon as you are done asking them, if you are done asking them, I want to give you everything I have of yours. I'm going to do that so I don't forget.
Yes.
No, may still forget. Anybody got any questions? Anything about probability, content, situations, particular problems? Something you're looking at on your phone right now that you want to share with us? Anything like that? Just let's take a look. What do you got? What? Just wondering why you got your phone out, but that's okay. What do you got, man?
There was one question that we did a while ago, but it was about like some people are sitting at like a circular table and then one person always has to be nearest to the door. And that's one spot. And I kind of forgot how to do this.
Okay, so the idea about one person sitting in one spot, what that does is essentially introduce a class. Because, like, for instance, if there's a round table in this room, just a round table, and forget the room, there's just a round table and people sit around it. Because they have not mentioned anything about the context of the room, we're kind of just like putting blinders on and saying, like, if you think about it, if everybody was sitting at a chair and everybody stood up and moved one chair to the left, it wouldn't really change anything, would it? Right? But, like, and I think I may have given an example of my wife in this class or the other class. When we sit down at a table, right, maybe on opposite sides of each other so we can chat or whatever, she always wants the best view. So she sits down and she finds the view she likes. And yeah, I might prefer a better view than a concrete wall, but I don't care that much. I know it's more important to her, so I'm like, sit where you want to sit. So the point is, when you start introducing outside influence, that can take away your circularity. So if I say something like, hey, yeah, ignore all this, but if I said, hey, we've got this circular table, how many ways can you arrange 7 people on it? Well, because of the circular nature of it, I go 7 minus 1. Like if I have 7 people, I would say 7 minus 1, which is 6, and I would say 6 factorial. But if I said, hey, there's this seat near the door, right? I got the door right here, and there's a seat right here, and I need to leave it open because somebody's coming late, they need to slip in the back. Well, all of a sudden now, if I have to arrange 7 people in the remaining seats, I'll make those squares, whatever. In the remaining seats, if I'm arranging those 7, if I have to keep this open, then basically these 7 seats I'm arranging them in, it suddenly becomes kind of linear. That makes sense? So if that has to be stuck right there, I have to leave that open, then it no longer is it linear. I would say 7 factorial.
Oh, it's like the
However,
necklace with a clasp.
like the necklace of the clouds, it basically introduces something to that circle that takes away the circularity. Now, if I say one of those 7 needs to sit in there, so I have to literally, then I have to go, well, how many different options are there for that seat? 7. I would say, okay, so there's 7 there, 7 ways I could do that, and in the remaining 6, it would be 6 factorial. Or what if I said, hey, there's 7 people, one of whom is Biff, okay? And Biff has to sit in this seat. Well, in that case, what do I do? If Biff has to sit there, there's only one way for one seat for Biff to sit in, but the remaining 6 people are what? In this linear situation, 6 factorial. So there's all kinds of ways I could manipulate that, but the key is if there's something about that circle that introduces some fixed situation, whether it's a perspective or some actual seat or whatever, that could be a column. What if I said, hey, there's this column in the room right here, right? Well, then obviously if Biff is there and there's a column right to his left, like if I said, hey, how many ways can you arrange people in these 7 seats right here? Okay, how many ways can you do that if there's a giant column right there at the edge? Well, that changes things, doesn't it? Because now if Biff is here, he might not be able to see Susie, as opposed to, and Monica, maybe he can see Monica but not Susie. But if they rotated, now he can see Susie but not Monica. Well, again, something introduced a fixture to that, some interference to the perfect circularity. So I would say, well, in that case, I have 7 seats and they're all linear. Not if I just said 7 random people. So there's all kinds of things that could change that. But the key is, if it is perfectly circular and nothing's interfering with that perspective, decrease it by 1. And then remember, if it's flippable, like necklaces and maybe keys on a ring that you put your keys on, or a charm bracelet, those are not only circular potentially, but they're also flippable. And if it's flippable, what do I do? Divide by 2. But you don't flip a table with people, right? I can't go, hey, I need to change my order up here. That's not an option. But I could take my necklace, my charm bracelet, I'll put it on the other way, and I technically didn't change anything, except I flipped it, but I now have a new order. Well, that halves all of it, so I'd have to divide by 2.
So if it was just 7 seats and there were no inclinations to somebody having to sit in a specific spot or a seat remaining open, how would you solve that normally? Would that just be 7 factorial since there are 7 seats and it doesn't matter?
Circular or non-circular?
Circular.
So if there are 7 seats in a circular situation like we've been talking about, 6 factorial. If nothing else matters, you decrease it by 1. It literally, you say 7 minus 1 factorial.
Right.
If it's circular.
But then if one of those seats was said to be left open, it would just be.
So then you have to have 8 if you're going to leave one open, right? So if you had 8 seats and you leave it open, then the 7 remaining act linearly. the thing that's annoying to people is sometimes you're like, wait a minute, I get the same answer.
Yeah, that's
And it
what.
starts to be confusing. Don't worry about that. Don't worry about it. Trust the math.
All right.
Yes.
Can you do the example that you did when we first did the circles, where it was like semicircle that's cut off and the line? I don't remember the exact example, but it was like, you have 15 charts that you could put on there or something like that, and you were trying to figure out. I
I
gotta
think the
think.
remember
semicircle
what you were
one was
saying.
dots, and I was trying to connect dots to make
Yes.
shapes.
Yes, into triangles. And
Would I just do a different problem like that? Is that what you're asking?
yeah, just something like that, because I.
Okay, why don't I,
I've been
instead of
it
just
for
doing what I did
years.
earlier, why don't I say, instead of before where I was just counting the number of ways, why don't I find the probability and shake things up a little bit?
Sure.
Okay, so what if I gave you this semicircle or whatever, it won't even be a semicircle, it'll be something weird. And I have 5 dots there. 9 there. And I want to say, what is the probability of getting a quadrilateral? And if I choose, so I'm going to choose 4 dots randomly. What's the probability that I get a quadrilateral? So how do I find the probability that I get a quadrilateral? I would have to find the number of ways I could get a quadrilateral over the number of ways I could just pick 4 dots, right? So how many ways can I get a quadrilateral?
Lots of ways.
Okay, so what are the options? I could certainly pick all 4 dots from the curve, right? So I could pick all 4 dots from the 9 dots. So definitely 9C4. That definitely gives me a quadrilateral. Or what could happen?
You could take 1 from the bottom.
And 3 from the top. So that would be 9C3 and 5C1. Or I could do what?
2 from the bottom?
2 from the bottom and 2 from the top. That would be
Nice.
9C2 and 5C2.
And then-
But can I pick 3 from the bottom?
No.
3 from the bottom and 1 from the top gives me a triangle. 4 from the bottom and none from the top gives me a line. So that would be the number of ways I could pick, get a quadrilateral, right? The probability says to divide that by
the number of ways you can.
the total, which would be 14, C4. And I could divide each one by 14 C4 or just do this. Right?
That's not as hard as that.
Yeah.
Now, You know what I could also do? I could also, remember we talked about the probability of getting something is the same thing as 1 minus the probability of not getting something. What's the probability of not getting a quadrilateral? I'm sorry, what's the probability of getting a quadrilateral thinking that way? So I have to go 1 minus. So the probability of not getting a quadrilateral is just the number of ways of not doing it over the total. And what did you say were the ways I couldn't get it?
If you had 3 from the
3 from the bottom and 1 from the top. So that's a 9C1, 5C3, or what? Or a 5C4. So I could do that also. All right? And actually, if I make this a triangle problem, it's even easier. Think about it. What if I said triangle? So I'm choosing 3 dots, and I'm probability of getting a triangle. I could definitely get all 3 from the 9, right? Right? I could definitely get 2 from the 9 and 1 from the bottom. Or I could definitely get 1 from the 9 and 2 from the bottom. 14C3 on the bottom. Right? Doesn't seem much harder that way, right? Pretty much the same thing. But look at this. What's the only way to mess this up, picking 3?
You pick them all from the bottom.
Pick them off from the bottom. So really, this would have been a whole lot well, not a whole lot easier, but this would have been significantly easier just to go 1 minus. Right?
Oh, yeah.
You seeing this?
Yes.
Now, what if I change it from probability? And somebody asked me about this. They said, I think, might have been somebody, oh man, hold on.
It'll be a long video.